My name is Brianna Hernandez, and today we'll be learning about constructing graphs for categorical and quantitative data.
Learning how to construct graphs is an essential skill in statistics that makes patterns in data easier to see. Let's start with learning the difference between categorical and quantitative data. So categorical data deals with names or labels, and an example is favorite fruits or car brands, while quantitative data deals with numbers that measure something, such as test scores or height. The type of data determines which graph is appropriate. The type of charts that we'll be using today are bar charts, line charts, dot plots, and stem and leaf plots. Our first example today is going to be bar charts. So an important thing to know is that bar charts use the height of the bar to display the amount in a particular category. For our first scenario, we're going to be talking about favorite fruits. So a teacher asked 20 students their favorite fruits. We had the responses of 6 for apple, 3 for banana, 7 for mango, and 4 for grapes. So to start constructing your bar chart, you create a X and Y axis. And on the vertical side, you're going to put your frequency, which is the lowest is 0 and our highest is 7. So we're going to put those tallied. 3, 4, 6, 7. And then on the horizontal part, are going to put your categories. So I'm going to put the first letter for each category. So A for apple, B for banana, M for mango, and G for grapes. So each category gets a bar. Each category gets a bar. So our first category is apple, and there was 6 responses for that one. So we put a bar up to 6. And for bar charts, they do not touch. So then 3 for banana, 7 for mango, and 4 for grapes. And then lastly, you always want to label your graphs. So I'm going to name it favorite fruits. Favorite fruits, excuse the handwriting. And then always label your axes. So this can be your frequency on this end and then your fruits on this end. I just don't have enough space, so we're just make sure to always label. For a line chart, when a quantitative variable is recorded over time at equally spaced intervals, that forms a time series. And line charts most effectively present time series. So for our second example, we're going to use the scenario that a group of students aim to monitor their study habits over a 5-week period to understand how their study time varied. Each student recorded the total number of hours they studied each week. So for week 1, the students recorded 10 hours, week 2, 12 hours, week 3, 15 hours, week 4, 14 hours, and week 5, 16 hours. So to draw a line chart, we're going to start just like we did for a bar chart and draw an X and Y axis. On the horizontal, we're going to put the week. So we're going to put week 1, week 2, week 3, week 4, and week 5. For our vertical side, we're going to put the number of hours. So I'm going to go up by 2 and start at 8. So I'm going to start 8. Eight, 10, 12, 14, 16, and 18. So in week 1, they studied for 10 hours. So not like the bar, you're just gonna put a dot where it lines up. So 10 in week 1. Then for week 2, I'm going to put it up to 12 hours. Week 3, 15 hours. So since we don't have a line, we're going to put it in between the 14 and the 16. Week 4, we're going to put it up to 14 hours. And week 5 to 16 hours. For the line chart, how we connect them is we draw a line to see how it goes. So that's our line chart. And once again, always label. So I'm gonna put study. I'm gonna label it in a different color for you. Put study time as my heading. And then label that these are the weeks. And label that these are the study hours. For our third example, we are going to be creating a dot plot. So dot plot are also known as the simplest graph for quantitative data. For our example today, we're going to say our teacher surveyed her class to find out how many minutes each student takes to commute to school. The data collected was the following, which was 5, 10, 10, 15, 15, 15, 20, 20, 25, and 30. So to create our dot plot is very simple. So we're going to do a horizontal line and start labeling. I'm going to go up by 5. So I'm going to start at 0, 5, 10, 15, 20, 25, and 30. So now we're going to put dots at each column that corresponds to our data. So we're going to put only 1 at 5. We're going to put 2 under 10, 3 under 15, 2 under 20, 1 under 25, and 1 under 30. And make sure to always label your graphs once again. So we're going to put time commuting. Lastly, we're going to talk about our stem and leaf plots. So we're going to go step by step on how to construct one. First, I'm going to read out the example and then we will read the instructions together to build it. So a teacher wants to analyze the distribution of scores from a recent math test to understand how the students performed. The test scores are out of 100 and the data that she collected is listed right here. So now let's go through the steps to construct one together. So first step is you're going to divide the measurement into 2 parts. So the stem and the leaf. The stem and the leaf. And you are going to draw a line. And so the stems are going to be the tens of the numbers. And the leaf is going to be the ones of the numbers. So the only things that we have are 7, 8, 9. And let's put 10, but it's going to be empty. And let's add a 6. So we can always have 1 over and 1 under. So there's nothing under the 6s. And for 70s, we have 72. So we're going to add a 2. We have 76. So we're going to add a 6. We have 78. So we're going to add an 8. Under the 80s, we have an 84. So we're going to add a 4. We have an 85, so we're going to add a 5. We have an 88, so we're going to add an 8. An 89 was our last one. Under the 90s, we have a 0, so you do mark that 0. We have a 91 and a 95. So you always want to go from lowest to high, lowest to highest. And you always wanted to provide a key. So our key is going to say an example. So we're going to put 70 represents 70, as in 70%. And that's our key. And once again, always label your graphs.
That concludes today's lesson, and always remember to label and title your graphs.